look, today is Monday the 10th, and you have a test on Friday. So today we're learning the last two, well, today and tomorrow, the last two sections. So in your book right now, this is notes from section 9.7, and tonight for homework is Delta Math 9.7. So in your book, if you were like, hey, I don't know how to do it, you could look it up. It's in chapter 9, section 7. And today we're talking about the law of signs. So it turns out, up until this point, everything that we have been doing has been right triangle trig. 95% of trigonometry is right triangle trig. And after you learn all of this stuff about right triangles, it turns out that we have two formulas that actually work for any type of triangle. So the law of signs can be used to find length and angle measures of any triangle, not just right triangles, all right? Kind of interesting. So first of all, we need to talk about the anatomy of a triangle. You can see here is a great graphic. When we have name a triangle, we use capital letters to represent the vertices of the triangle. So we have capital A, capital B, capital C. Those are vertices. Then opposite angle A is side A. And we use lowercase letters to represent the side lengths. So opposite angle B is side B with a lowercase b. And opposite angle C, we have side C. And that's true no matter what letters you use. So for instance, if I were to give you a triangle GHI, which you're going to see in Delta Math.
Is I is connected to, or is in between GH?
Yeah, so opposite angle I, we have lowercase side length I. Opposite angle G is lowercase g, and opposite angle H is lowercase h. And so just keep that in mind. All your triangles are going to have lots of different letters, okay? And I encourage you to draw a picture. But you always have your angle and opposite side, uppercase, lowercase, okay? All right, so it turns out that if we have a pair like opposite angle information and the side, I can write a really easy ratio. The sine of angle A over its little opposite side lengths. So the sine of A over lowercase a is equal to the sine of angle B, over lowercase b over the side length b. And the sine of angle C over its opposite side. We can use these little ratios and could create a proportion, which we've been solving all day, all right? We've been solving for weeks now, proportions. And that's all we're doing today. We're just writing proportions using this little sine of the angle over the opposite side. So let's look at number one. So on number one here, I have this angle 71, and its opposite side we're trying to figure out, which we've called x. I also have this 35-degree angle, and its opposite side 12, so I can use that information to set up a nice little proportion. Sine of 71 degrees over its opposite side x is equal to sine of the 35-degree angle over its opposite side of 12. So we create this lovely little proportion with our little angle and side pairs that we've got here. How do we solve? Cross multiply, absolutely. Now, like always, I'm going to start with the thing that has the x on it. So this is going to be x times the sine of 35 is equal to 12 times the sine of 71. All right, I'm trying to get x by itself. What do I need to get rid of? Sine of 35. How do we get rid of it? Divide by the sine of 35 on both sides. Dividing top and bottom by the sine of 35 goes away. So we get x equals, now in your calculators, we're going to plug this whole thing into our calculators. What mode should your calculator be in? Degree mode, because they're, you go to mode, the mode button is right at the top there, and you just go down to where it says degree and hit enter. Alright, so we're going to do 12 sine of 71 over the sine, over the sine of 35.
9.97.
What'd you get?
9.97.
That's not what I got. 19.8. We're going to round to the 10th place. Are you in degrees? Okay,
Mhm.
yeah. Alright. Let's look at number 3. Alright, I have a 73 and I have its opposite side of 20. What can I write? Sine of 73 over 20 is equal to sine of 59 over sine of 59 degrees over x. Remember, when we use sine, cosine, and tangent, they have to have an angle measure attached. So we need degrees with that in order for it to work. All right, let's cross multiply. So again, I'm going to start with the thing that has the x. So that's going to be x times the sine of 73 equals 20 times the sine of 59. And how do you get x by itself?
Divide by the sine of 73.
Divide by the sine of 73. Alrighty. So we get in our calculators. I get to just type that in. A good idea just to do it along. Make sure you're getting the same answers as me. So pretty easy to type that in directly. And we get 17.9. Let's look at number 4. On number 4, I have this lovely little 96-degree angle in its opposite side. What can I set up with that?
27.
Okay, so sine of 96 degrees over 27 is equal to, Now this one, I have the 53, but I need to find x. So if I have that opposite side x, I need this angle measure. So I need to find that angle measure. How do we find that?
Would you just add up the angles, or add up the angles and subtract by 180?
Yeah, subtract from 180. So we have 180 minus 53 minus 96. That'll give us our lovely little angle measure, 31 degrees. So a lot of the problems in Delta Math today are, you're going to have to figure that out. You need an angle before you can do the rest of the problem. So we can write the sine of our 31-degree angle over x that we're trying to figure out. Okay, and from there we can cross multiply.
X times the sine of 96 degrees.
X times the sine of 96.
27 times the sine of 31 degrees.
Equals 27 times the sine of 31, and then? Divide by the sine of 96. Good. Divide by the sine of 96. Great. And if we type that into our calculator, 27 sine of 31 divided by the sine of 96, I get 13.98. If we round it to the tenths, it becomes 14.0 or 14. Either one will be fine. Questions so far? Is this easy or hard?
Easy.
Ready? Easy? Let's do the last one, number 6 here. What do we need to do?
180.
Find the missing angle, yeah, because our x needs that opposite angle, so we absolutely need to figure that out. 180 minus 33 minus 58, 89. Okay, so that angle's 89 up there, 89 degrees. So we can write the sine of 89 degrees over x equals what over what? Good, sine of 58 degrees over 25. Okay. We go ahead and cross multiply then. X times the sine of 58 equals 25 times the sine of 89. And then we need to
divide by the sine of 58.
Divide by the sine of 58. Good. So what's really important that you write down today? The setup. Absolutely essential. You are probably going to have to draw some triangles just to get an idea, but once you write down the setup, it goes pretty good from there. All right, 25 times the sine of 89 divided by the sine of 59. Oops, thank you. 58. Oh, 58. There we go. Better. Thank you so much. All right, we got 20. Whoops-a-daisy. Ah, that was supposed to be 89. Okay, you know what? Let me try that again. Oh, I totally messed up on that. I put 20 and not 25. Sine of 89 divided by the sine of 59. Whoa, okay. 29.5. What am I messing up on here? Oh, I don't know what I was writing. 25 times the sine of 89. Yeah? 89. Over the sine of 58. No, 58. I don't know where I wrote 59. Okay, Lord have mercy. There we go. 29.5 is the right answer. Sorry about that. Okay. So all of that was finding side lengths. And it also works if we need to find the angle measures as well. So turn the page. Let's look at some angle measures. Same process. Nearly. So I have an angle and I have its opposite side. What can I set up?
Sine of 77 degrees divided by 14.
Good. Sine of 77 over 14 is equal to
X over 9.
Sine of x. Sine of a x angle. Again, it has to have an angle with it. Sine of the angle over 9. Same as before. Cross multiply. So just like before, this is an angle measure. So we can take the sine of the angle measure, sine of x. Oh, there, that makes a big difference. Oh, you were on number 7. Got it. Well, that's a lot harder. Let's cross multiply. Again, I'm going to start with the thing that contains the x. So I've got the 14 times the sine of x degrees equals 9 times the sine of 77 degrees. Now, this is a little bit different. I need to try to get the x alone, but right now it's trapped inside a sine function. What can I get rid of right now? 14. So yeah, we can divide by 14. So I'm going to get rid of the 14. So divide by 14. So now sine of x is alone. And I'm going to go ahead and put this whole right side into my calculator. Otherwise, the calculations just get a little bit messy. 9 times the sine of 77 divided by 14.
0.626.
Okay, so that gives me 0.62638. Now, we're going to use the calculator to carry that big long decimal. But before I get there, right now the x is trapped inside a sine function. How do I get rid of that sine function? The opposite, which is called inverse. Yeah, sine inverse. So we're going to do the sine inverse of both sides. That undoes that crazy complicated sine function. So sine inverse and sine cancel one another out, leaving x alone.
With 38.8.
True. So what we're going to do now, the easiest thing to do In my calculator, we're going to do second sine inverse, so I've got my inverse function there. Now what I want to do is I want to call up that whole big long decimal. Second answer, yeah, is the best, quickest way to do it. You can arrow up and highlight and bring it down, but second answer is at the bottom, A and S, and it's blue. And second answer is the best way to do that. It's super fast, and it calls up the previous answer. And so we get 38.8 degrees. And again, this is X, it's an angle measure, it has degrees on it. Okay, let's try number 11. All right. So I have a 61 and a 24. What can I write down?
The sine of x degrees over 21 equals the sine of 61 degrees over 24.
All right, sine of 61 over 24, and then we have the sine of x degrees over 21. Lots of ways to write that down. We're going to cross multiply. I have 24 times the sine of x equals 21 times the sine of 61. What do I need to do next?
Divide both by 24.
Divide by 24. Good. That's going to give me sine of my x equals, and all of this I can put in my calculator pretty quick here. 21 sine of 61 divided by 24. We get 0.4373. And then how do you release the x from the sine function? Inverse, sine inverse of both sides. Sine inverse and sine undo one another, freeing the x. And in my calculator, we're going to do sine inverse, second answer. And we get 25.9. That is not what you got. What the heck happened to mine?
I got 49.9.
49.9 is totally right. Well, oh, I typed in 12, not 21. Brilliant, Amanda. Right, 21. Oh my God. Have you never heard that before? My brothers used to say that to me all the time.
That's the funniest thing I've ever heard.
So, that was not that decimal. It should be 0.7652. Okay. So then, sine inverse of the answer, there we go, 49.9 degrees. Sorry about that. I've done this too many times today, clearly. Okay, questions so far?
Nope.
One more? One more. I'm not going to mess this one up this time, promise. All right. Curtis, walk me through. Go ahead.
So you're going to sine 94?
Uh-huh. Over?
43.
Okay. Is equal to? Sine of? Over? Yeah, 37. And then we're going to cross multiply. Which gives me what? I'm going to start with the 43. 43 times? Equals? 37 times the sine of 94. Good. Look at that. Brilliant. All right. How do we get the sine of x all by itself? How do you undo multiplication? You divide by 43. Great. So we have sine according to angle x. We're going to plug all this into our calculator. I'm not going to screw it up this time. 94 divided by 43. So that gives me 0.858. And then how do you get x all by itself? sine inverse of both sides. Sine inverse and sine undo one another. And in our calculators, we can do sine inverse, and then second answer, and that'll use the previous answer. 59.1 is great. 59.1 degrees. Ladies and gentlemen, do you have any questions for me?
Nope.
All right, you have a Delta Math. Refresh your screen. Draw pictures because they're going to make you, this is one of the problems from Delta Math on the board right now.